Hello, this is going to be part 2, and I think it's going to actually have sound this time, so thank you for those that were waiting for this one. This is going to be the last part of review number 5. And we have a graph in front of us of g of x, which is equal to the integral of -1 to x of f of t dt. I just wanted to make sure that we note one thing that I always like to do with these integrals. I have this function equal to this integral. I like to know what g prime of x is. And g prime of x is going to be equal to f of x. That's the fundamental theorem of calculus part 2. Which means, and the only reason that this really matters at the moment, is that when I want what I'm looking at of this graph, it says f. I am actually going to cross that out, and I'm going to say that this is actually g prime. The reason I write this down, even though I might know it already, and the reason that I cross out that f and go to g prime is so I'm letting my reader understand that I know the relationship between f and g. G prime is f, so this graph that they're giving me is actually just g prime. But I do that every single time that I have a function equal to an integral, with that integral having an x at the top or some variable in the limit of integration. Okay, so now let's go ahead and do what we need to do here. We're going to look at g of 2. So g of 2 is going to be straightforward, hopefully. G of 2 is going to be the integral from -1 to 2 of f of t dt. And if you remember what the definite integral represents, it means that I need the actual area between -1 and 2. And if I calculate that, it looks like I have a, let's see, this looks like a -3 area, or a -3 value. And over here, it looks like I have 1. The reason I got that is this part is a triangle, and it looks like it's a 1 by 6 rectangle, but the triangle is half, so a -3. Similar reasoning for this area. Base is 2, height is 1. 1/2 times 2 times 1 is 1. All of that means that my area is going to be -2, which is what g of 2 is going to be. So g of 2 is going to be -3 plus 1, which is -2. For g prime of 2, well, g prime of 2 is going to be equal to, let me scroll down here. Okay, g prime of 2 is going to be equal to, oh, great. I just need to find the actual y value on g prime. And g prime of 2 is going to be right here, and it's a y value of 1. So g prime of 2 is 1. For g double prime of 2, I need the slope of g prime at 2. So I'm just going to put in parentheses here, slope of g prime at x equals 2. Okay, and the way I knew that is that g double prime is the slope of g prime. And in order to get that, I'm just going to look at the graph and see what the slope is. And it looks like the slope at 2 is going to be going up 1 and over 2. Up 1 over 2. That's a slope of 1/2. So g double prime of 2 is 1/2. Okay, that's A. Let's go to B. Duplicate this page. Duplicate, please. Okay, let's do this. So, for the next part, for B, find the average rate of change of g on the interval 0 to 6. Alright, so one thing I'm noting about 0 to 6, one thing that I'm noting about for the average rate is it's of g. So the first thing I'm going to do is I'm going to interpret this average rate of change of g and just make them very happy here. I'm going to say g of 6 minus g of 0 over 6 minus 0. That's the average rate. So I'm going to write that down and communicate to them that I actually know what they're talking about there. Next, I'm going to have a 6 in the denominator, and now I need to actually find what g of 6 and g of 0 are. So g of 6 is going to be, so g of 6, and we'll do g of 0 in this color, fancy colors. G of 6, not calligraphy pen, is going to be, well, if I want to get any y value on g, I have to use this formula here. So g of 6 is going to be the integral from -1 to 6 of f of t dt. And now let's find that area. I already found the area from -1 to 2. So let's find to 6. Let's see here. I think that this part was a -3. I'm just going to look at this entire triangle here, which is half of the big rectangle. So it looks like this is going to be a 4. This triangle is half of this rectangle, so that's going to be a 1. And we've got a little itty bitty triangle here, and that's going to be a -1/2. Okay, again, each of these values here I found by finding the area of the dashed regions. And why did I find the area of the dashed region? It's because an integral represents area between the curve and the x-axis, the function of the x-axis. Okay, so that means that the area from the accumulated area from -1 to 6, or the accumulated values rather, is going to be equal to -3 plus 1 plus, what was the other numbers here? 4 and then -1/2. So plus 4 and then -1/2. And that gets me, let's see if I can do my math here, to 1.5. Now if you find a mistake on this, I want you to be quiet because I don't want to know that I made a mistake. So we're going to do 1.5 here. And then we're going to do minus, and now I need g of 0. And g of 0 I think will be pretty straightforward because we already calculated that before. G of 0 will be the integral from -1 to 0 of f of t dt. And that area looked like it was just this part, which is -3. I'm sorry about making horrible dashed lines on this. But this was equal to -3. So it's going to be a 1.5 minus a -3, which is 1.5 plus 3, which is 4.5 over 6. And you could leave your answer as is if you want. If you want to simplify that, go for it. Let's see. That is going to be 3/4. But that's your answer for the average rate of change. And again, if you find a mistake, just don't say anything. Andy, I'm talking to you, Andy. Do not say a single thing. I don't want to hear it. Same with you, Eddie. All right, for part C. Andy and Eddie always like to point out how imperfect I am, and then they laugh at me cruelly afterwards. Okay, let's see. Next. Let's go and get C. Oh my God, there's 5 parts here. Holy moly guacamole. There's this off. So for part C, it says how many values of C on 0 to 6 is G prime of C equal to the average rate of change in part B? So remember the value in part B was 3/4. So how many values of C where 0 to 6 is G prime of C equal to the average rate of change found in part B? Okay, so they want G prime of C equal to 3/4. 3/4 was from part B. And I did this very sloppy line, so I'll just put in a nice clean line here. And it looks like it's going to be 2. Now, the only thing that some students might find confusing about it, so here's 2 points that are intersected by that horizontal line. Now, the only reason that some people might object to that is this point at C at x equals 4 is non-differentiable. But it doesn't say for how many values of C does the mean value theorem guarantee. It just says for how many values of C on that interval is G prime equal to the average rate of change, and that is 2 times. So this answer is going to be 2. Next, find the x-coordinate of each point of inflection on -2 to 6 of G. Now, of G, they do give me G prime here. Remember that this is the graph of G prime. So the question is actually asking, how can you determine a point of inflection of G based on G prime? So, from G prime. That's what it's really asking. And to determine a point of inflection from based on the graph of G prime, if you remember from your oral exam, we are looking for maxima and minima of G prime graph. any relative max or min on the open interval will give you a point of inflection on G, which means that I am looking at this guy and that guy. Those are my only two points of inflection on G prime. I'm sorry, those are my only two max and min on G prime on the open interval from -2 to 6. So the x coordinates are going to be x is equal to -1 and x is equal to 4. It doesn't ask us to justify, but I'm going to tell you, you probably should anyway, just so you're in the habit of defending your reasoning and being concise. The reasoning is because G prime changes from increasing to decreasing or decreasing to increasing. Changes from, and I'm going to use abbreviations here. You would write out the entire word, the entire phrasing on the test. And notice I use the actual word because and not B over C. So because G prime changes from increasing to decreasing or decreasing to increasing at those points. So decreasing and increasing. And now let's go on to the last part, which is E to increase. Okay, E. Determine h of x equals x. So define h of x to determine if there's relative min, relative max, or neither. Okay, so let me duplicate this page. And let's go and clear this. This is a trick that Courtney Schmidt taught me. Cleared all the ink from the page. It's been a lifesaver. Okay. Determine if there's a relative max or min or neither for h. Well, if I want to know if there's a max or min for h, I actually need to be able to take the derivative to find it. So h prime of x is going to be equal to g of x, product rule. Derivative of the first is 1. Keep the second, plus derivative of the second is g prime of x times x. And I need to set this equal to 0. So I need to set h prime of x equal to 0. This is for part E. And what happens here is I get g of x plus g prime of x times x equals 0. Now I'm really interested in x equals 2. So I really need g of 2 plus g prime of 2 times 2 equals 0. Well, let's see here. Oh, tricky. All right, g prime of 2 we already had. I think g prime of 2 was 1. So we have 1 times 2. That was found in a previous problem. I think g of 2, if I don't remember. G of 2 was equal to -2. So g of 2 is equal to -2, and then that means that's a 0. Wow. All right, that's good. I want that because I want there to be a slope of 0 if I'm going to have a minimum or a maximum. If there is a slope other than 0, then the graph of h would actually have if the graph of h did not have a slope of 0 at x equals 2, then I would neither have a relative max or min. Okay, so finally, I'm going to do h double prime here. The reason I need h double prime is this question was asking for a second derivative test, because that's the only other way I would actually be able to determine if I have a relative max or min. So I'm going to do g prime of x plus product rule here, g double prime of x. So that's the derivative of the first, keep the second. So times x plus derivative of the second and keep the first, so g prime of x. This could be simplified to 2g prime of x plus g double prime of x times x. And then I want h prime of 2, and I want to see if this function is concave up or concave down. So I get 2 times g prime of 2 plus 2 times g double prime of 2. Okay, let's see what my values are here. I think I have all those values. So g prime of 2 is 1. So I get 2 times 1 plus 2 times g double prime of 2. I think we calculated that too. And that was a slope, I think it was a half. Yeah, it was up 1 over 2, so that's a half. And I'm not really interested in the number, but I can get it anyway. That's 3. 3 is positive, which means that this function is concave up. Again, second derivative talks about concavity, so this function is concave up. So because g prime of 2 equals 0, and G double prime of 2 is positive. Oh, and actually, hold on just a second here. I used the wrong letters. This should be H. And then I'll be all done. I'll get at, you guys can resume your lives afterwards. So H prime, H double prime equals 3, which is positive. Then H, so H has a max, has a min, has a local min at x equals 2. Thanks for watching, guys.